Hello, third grade, and welcome to Module 3 or Chapter 3. In this chapter, we're going to focus on weather and climate. And for Lesson 1, we're going to focus specifically on weather changes. Let's go ahead and watch our short instructional video, and then we're going to dive into our pages.
Hi, I'm Grace. I just love everything about technology. My mom is a computer programmer. Her inspiration was Grace Hopper, the inventor of a programming language that used words rather than numbers. My mom and Grace Hopper are my heroes. I want to be just like them. I want to learn to develop websites, write computer code, and create really fun apps for my friends and me to play.
All right, let's take a look at our first set of pages. Now, if you open up your books, let's actually skip ahead to page 90 for the beginning of our lesson. What happened to the puddle? So you'll go ahead and read through this passage and read through the different friends' ideas of what happened to the puddle in the story. You're going to write who you agree with, and then you're going to explain why you agree. Remember to use complete sentences and to pull part of the question into your answer. For the next part, it says, look at the photo of the extreme weather. What questions do you have? So let's take a look at the different photos that we have. There's more than one. So here are the different photos of extreme weather that we have for this section. Take a minute to look over them and then go ahead and answer your question. Once you've completed that, you're going to read about the STEM career connection. And this week, we're going to talk about a meteorologist. You're going to read what a meteorologist does and the importance of their job. And then you're going to answer the questions on the following page. Why do meteorologists analyze and interpret data? Why is it important for a meteorologist to provide good information? Once we've completed those pages, we're going to go on to our first activity. Now, our inquiry activity for this lesson is called Air is Around You. And it's asking you, how can you confirm the presence of air? How can you prove that there's air around you? So your question, where you have to make your prediction, asks, can air keep a paper towel inside of a cup from becoming wet? So you're going to use the materials a plastic container, water, paper towel, and a plastic cup. Now you're going to follow the steps to fill the container, to put a dry paper towel into the bottom of the cup and hold it upside down and then push it straight down into the water without tilting it. You want it to go straight down into the bottom of the container so it's sitting flat at the bottom. And then it says to lift the cup straight out of the water without tilting it. You're going to write down how the paper towel feels. Then you're going to repeat it slowly and you're going to tilt the cup this time and write down any observations that you have. On the following page where it says communicate information, number 1, what escaped from the cup in step 4? Number 2, how did your observations compare with your prediction? And then for number 3, draw and label your activity when the cup is in the water and show where the air was. So draw it out in this bottom section on page 94. Make sure you label all of the parts and do your work very neatly. If you are not in class when we do this activity or you're not available, I do have a video that I'm going to add into Google Classroom that shows this activity being done. Let's go ahead and watch this activity quickly.
Hey everyone, it is Danielle from Cool Science Experiments Headquarters. Everyone, it is Danielle from Cool Science Experiments Headquarters, and I am back with a new fun experiment for today. And we're going to take some paper towels and we're going to submerge them in a bucket of water. And they're not going to get wet.
How does that work?
That is a great question, and I'm going to show you how in just a minute. Are you ready? Let's get started. To start the experiment, we're going to tear off a piece of paper towel. And then we're going to put it in the bottom of an empty glass. we're going to turn the glass upside down, and we're going to submerge it. I'm actually going to push the paper towel back up to the bottom of that glass. You want it to stay at the top. And then we're going to submerge the glass under the water. Go ahead. And as you can see, the glass is completely under the water. So now let's lift it out and see what happened. Okay. Now I'm going to pull the paper towel out of the glass, and as you can see, the paper towel is still dry. Can you tell me how the experiment worked? Why did the paper towel stay dry? Leave a comment below to submit your guess, and then visit coolscienceexperimentsheadquarters.com to find out the answer. You'll be able to print out instructions for this experiment, and you'll find many more that you can do at home too. Thanks for watching, and we'll see you next time.
I hope you enjoyed the
Okay, now that you had a chance to watch the experiment, that's some information that you can use while you are trying to work on it from home if you're not able to replicate this experiment at home. Once those pages are completed, we're going to go on to our vocabulary page. Now, the vocabulary words we're going to focus on for this lesson are weather, atmosphere, precipitation, air pressure, wind, and cloud. Let's go ahead and review what those vocabulary words mean. Okay, so our vocabulary word weather is what the air is like at a certain time and place. So what was the weather like yesterday afternoon? What was the weather like when you got up in the morning? It's what it was like at a particular time and in a particular area. Atmosphere is the layers of gases that surround the Earth. So around the Earth, there are layers, and we call those part of the atmosphere, and there's different levels. Next, we have the word precipitation. And we said precipitation, this is one that we talked about before, is water that falls to the ground from the atmosphere. So if it's falling as rain or as snow or as hail, any form of water falling from the sky is called precipitation. Air pressure is the weight of the air pressing down on the earth. So pressing and pressure, those words are related. Wind is any kind of moving air, and a cloud is a collection of tiny little water drops or ice crystals that's found in the air. Now for this next part, we're going to read pages 152 and 153 in our science handbook to be able to answer questions 1 and 2 below. Where does weather occur, and what causes the air temperature to change? So let's go ahead and read through these pages. You're going to open up your textbook to 152 and 153, where it says weather and climate. Weather is what the air is like outside at a certain time and place. Even though you cannot see air, you can see it move things such as the leaves of trees. You feel air as a breeze on your face. Weather changes from day to day. It can also change from hour to hour or even minute to minute. The air that surrounds the Earth is part of the atmosphere. The atmosphere is a blanket of gases and tiny bits of dust that surround the Earth. The atmosphere has several layers. Weather occurs in the layer closest to the Earth. Temperature. When people describe weather, they describe the air and its temperature. Temperature is a measure of how hot or cold something is. A thermometer is a tool that measures temperature. The air changes temperature because of energy from the sun. The sun heats Earth's land and water. Then the land and water heat the air above them. The sun's heat is more direct at midday than it is at sunrise or sunset. Measuring air temperature. 30 degrees Celsius or 86 degrees Fahrenheit. The air is hot. It's a good day for a swim. At 10 degrees Celsius, which is 50 degrees Fahrenheit, the air is cool. And this is weather where you want to wear long pants and long sleeve shirts and probably have a jacket with you. And at 0 degrees Celsius, this is where water freezes. This is also 32 degrees Fahrenheit. This is very cold weather. You want a thick, warm coat to wear if you're going outside. Weather includes the clouds in the sky and water in the air. It includes the temperature of the air and how the wind is blowing. So let's go back and reread those questions. Where does weather occur? You can find that in the bottom of this second paragraph on page 152. And what causes the air temperature to change? That's also in the reading that we were just looking at. The air temperature changes because of energy from the sun, and because after the sun's energy warms the earth, the land and the water in turn warm the air around them. Now that we've completed those two questions, we're going to move on to the bottom part of page 95. And it says, according to the video, a meteorologist studies weather patterns. What does this mean? So we're going to watch the weather report and answer this question after we finish.
Looks like a big storm is headed our way. You might want to get a raincoat and an umbrella. And be careful if you are outside, as lightning is in the area, so do not stand under trees or be on rooftops. But tomorrow you get my sunny day guarantee. It will be warm and dry. How do I know all of that? Well, I am a meteorologist, and I have special tools and skills that help me predict the weather. And knowing the weather means people can be ready for it. I went to school to learn about meteorology, which means I understand weather patterns and what causes changes, and I use special tools that help me predict the weather. I use things like radar and a barometer and weather maps and satellites. So next time you see a weather report on TV, listen up. It will help you plan your day.
All right, now that we've finished watching the video, according to the video, a meteorologist studies weather patterns. What does this mean? So you can rewind the video and go back and rewatch that while the meteorologist explains what it means to study weather patterns, why that's important. Remember to pull part of your question into your answer and to use a complete sentence. Now on to page 96, we're going to read pages 154 and 155 in the Science Handbook, that's your textbook, and we're going to answer questions 4 and 5 on this page about what is precipitation and what is the relationship between wind and air pressure. All right, so pages 154 and 155, weather, describing and measuring weather. Air temperature is one measurement of weather. Precipitation, wind, and air pressure also describe weather. When one of these factors changes, so does the weather. Precipitation. Precipitation is water that falls to the ground from the clouds. Liquid rain is the most common type of precipitation. It falls if the air temperature is warmer than 0 degrees Celsius or 32 degrees Fahrenheit. Sleet, snow, and hail are frozen precipitation. Sleet forms when rain falls through layers of freezing cold air. Snow is made of ice crystals. Hail forms when rain freezes and is tossed about in tall clouds. Layers of ice coat the droplets, forming a ball. Eventually, hail gets so heavy it falls to the ground. Hail can be as small as a pea or as large as a grapefruit. A rain gauge measures how much precipitation has fallen. That's this right here. And then the arrow of the weather vane points into the wind. Air pressure. Air pressure is the force of air pressing down on Earth's surface. Weather reports often describe air pressure. When the air presses down a lot, air pressure is high. When it presses less, air pressure is lower. Low air pressure can mean that the weather will be cloudy or rainy. High air pressure often means that the skies will be clear. Scientists use a tool called the barometer to measure air pressure. Wind. Wind is moving air. It's caused by differences in air pressure. Air moves from places where air pressure is higher towards places where air pressure is lower. If these differences are great, the wind will blow hard and move fast. If these differences are small, the wind will blow gently or not at all. An anemometer measures wind speeds. That's this tool up here on top. And a barometer measures air pressure. Now it says, what is precipitation? You can go back into the reading and see exactly what precipitation is right here in this paragraph that begins with the word precipitation. And what is the relationship between wind and air pressure? That's also right here in this last paragraph that we read about how wind and air pressure are related. Read a weather report. When you interpret data, you use the information that has been gathered to answer questions or solve problems. It's easier to interpret data when it's shown in a table or a graph. Use a data table to make a line graph. Analyze the data in the table in your line graph. Which months are coolest? Which months are warmest? So take a look at the temperature. This is in degrees Celsius for Atlanta, Georgia, between January and December. Which months are the coolest? So you can say the coolest months are, and then put in your answer, and then the same for which months are the warmest. And we're going to move on to page 156 and 157 and answer the question, what do meteorologists use tools for? Predicting weather. Scientists use many tools to find weather patterns and predict how weather will change. They use tools that measure wind speed and direction, precipitation, air pressure, and temperature. A weather balloon is a tool that's launched into the air. It carries devices that collect data about the atmosphere. A satellite is a tool scientists put in space. It travels around the Earth and collects weather data over very large areas. A satellite can spot storms in the ocean. Scientists that use other information about the atmosphere. Scientists then use other information about the atmosphere to predict where the storm will move next. A weather map lists the temperatures, precipitation, and other upcoming weather predictions over a large area. It may show the high temperatures for the day. It may show where it will rain and where it will be sunny. Weather balloons are used to gather data about weather. So you can see a picture of a weather balloon over here at the top. And then down here in the weather map, you can see that the key shows you different colors and what they represent. So yellow is cooler temperatures up until that dark orange, which is high hot temperatures. We see the symbols for rain, thunderstorms, sunny weather, cloudy weather, or partly cloudy weather. You can see places like New York and Philadelphia and Portland, Oregon, and San Francisco have lower temperatures, but if you go towards Phoenix and Dallas, those have much higher temperatures. Scientists try to predict what the weather will be to help people plan their lives better. Knowing what the temperature will be helps people decide what to wear. Predictions of rain warn people to wear a raincoat or to take an umbrella. Farmers plan when to plant and how to care for their crops based on weather predictions. Knowing the weather also helps people stay safe. Airplane pilots study the weather. Weather predictions help them know whether it is safe to take off and then land in another area. Predictions of thunderstorms help people know when to plan indoor activities. Scientists can also predict when severe storms are likely to happen. Predictions of hurricanes can give people time to prepare. They can find shelter. They can leave the area if they have enough time. Meteorologist. Fascinated with the weather, a meteorologist studies weather and predicts upcoming changes in the weather. Turn to the career section to find out more about a career in meteorology. Predictions of severe weather can help people stay safe. All right, let's go back into our book. So what do meteorologists use tools for? Go back to the beginning of our reading. You'll find the information for that. Remember to use complete sentences and to pull part of the question into your answer. Now for this next section, it says you'll use tools to predict the weather where you live. What question will your research help answer? So you're going to use a weekly weather report and a current weather map. You're going to write what question you're going to answer, You're going to look at a current weekly weather report and create a bar graph that shows the high and low temperatures for each day. Look at a current weather map and look to the west of where you live, and then look to the east of where you live. Is there a relationship between the weather to our east and the weather yesterday? Were you able to answer your question? Once you've completed that, we're going to go down into the section titled The Water Cycle. So we're going to explore the digital interactive called The Water Cycle on how water affects weather changes. Then we're going to answer questions 11 and 12 on this page. What happens when water condenses, and what does water become when it evaporates? So let's move ahead and find that section.
Follow the guide through the steps of the water cycle. The water cycle. Water falls. When enough water has condensed in clouds, the water falls to Earth as precipitation. It can be rain, snow, sleet, or hail. Water flows. Some precipitation flows over Earth's surface. It flows downhill into lakes, rivers, and oceans. Precipitation can also soak into the ground. Groundwater flows underground through rock. Water condenses. Water vapor rises and cools. The water vapor changes into liquid water drops. The drops form clouds. Water condenses. Water vapor rises and cools. The water vapor changes into liquid water drops. The drops form clouds.
All right, now that we've made it all the way through our interactive water cycle, and we followed it from when it falls as precipitation, runoff that runs into the groundwater and into bodies of water, then evaporates and condenses, and then the cycle continues. So what happens when water condenses, and what does water become when it evaporates? You can jump back into our digital interactive to find that information. So when water condenses, and then what happens when water evaporates. So these two steps are the questions they're asking you about in your questions. Once you've completed that, we're going to go on to page 158 and 159 in our textbook and answer the following question. Question number 13, it says, tell about the information you can learn from clouds. Clouds. A cloud is a collection of tiny water droplets or ice crystals in the air. The color and shape of clouds can give information about the weather. Clouds can appear white or gray. White clouds allow a lot of light to shine through them. When clouds get very thick with water, it's hard for light to shine through. This is when clouds appear gray. Gray clouds often bring rain. Clouds are moved through the atmosphere by winds. This makes it hard to tell where and when rain may fall. Cloud shape gives weather watchers a lot of information. A cloud's shape cannot predict weather as well as data from other weather tools. However, each basic cloud type appears under certain conditions in the atmosphere. The three main types of clouds are stratus, cirrus, and cumulus clouds. Clouds filled with water droplets allow less light through, so they look darker than other clouds. Stratus clouds form in low, flat layers that cover most of the sky, like a blanket covers a bed. Stratus clouds can be white or gray, and they often bring rain or snow. Cirrus clouds form high above the ground. They are thin and wispy and mainly appear white. They show that the weather is fair, but precipitation may come in the next couple of days. And cumulus clouds are puffy clouds with flat bottoms. They often appear white when the weather is fair. Sometimes they look like one big cloud. At other times, there are many smaller cumulus clouds across the sky. When cumulus clouds darken, they may signal that rain or thunderstorms are on their way. So tell what information you can learn from clouds. Go back and talk about the different kinds of clouds and what kind of weather they generally bring or signal. You don't need to complete the I can statement. We're going to move on to writing a script. Okay, on page 168 to 173, we're going to go through and talk and read about different kinds of weather. So we're going to explore digital interactive weather events on different types of extreme weather and write a description for each one. We're going to use this table to organize all of the data that we collect. So you'll have 7 different photos. You're going to write the name of the kind of extreme weather where it says type of weather, and then details or information that you gathered about those kinds of weather in the details to include section. Please make sure, especially in sections like this, that your handwriting is really neat and clear so that I'm able to read it. All right, let's take a look in our textbook. Most of the time, people experience gentle weather, such as rain or snow showers. There are more severe types of weather as well. Severe weather can be dangerous to property as well as to people, plants, and animals. Weather scientists try to keep track of any severe weather as soon as it starts. They warn people about what to expect to their area. People can stay safe from dangerous weather if they listen to warnings. Some areas are more likely than others to have certain types of severe weather. Flatlands have different types of severe weather from coastal areas. And areas in colder climates have more snowy weather and ice storms. Different seasons bring different types of severe weather. Keeping an eye out for weather reports can help keep you and your family safe in all kinds of weather events. Scientists use tools such as radars to track severe weather. They warn people when to take shelter. Thunderstorms. A thunderstorm is a storm with thunder, lightning, heavy rains, and strong winds. Thunderstorms occur when different types of air come in contact with each other. A mix of warm and cold air or wet and dry air may cause a thunderstorm to form. The buildup of energy from the mixing of air causes lightning. Lightning is a static discharge similar to the one you might feel after touching a doorknob on a dry day. Thunder is the rumbling sound you hear after lightning quickly heats and expands the air. Lightning is a dangerous part of a thunderstorm, not thunder. Thunderstorms can also produce hail, sleet, or snow. Thunderstorm safety. Stay safe from thunderstorms by going inside. If you cannot go inside, avoid lightning by staying away from trees. Stay out of water and stay away from metal objects. Wait at least 30 minutes before returning outside to play after a thunderstorm. Thunderstorms are the most common type of severe weather. There may be 40,000 thunderstorms around the world on any single day. Tornadoes. A tornado is a severe storm with rotating winds that form over land. It looks like a big, tall funnel. Tornadoes form as the air between thunderstorm clouds and the ground begin to move and spin. Tornadoes can destroy buildings and pick up items as heavy as a truck. The force of winds can throw the items hundreds of meters away. The path of some tornadoes is narrow. Several buildings on a street may be damaged, even though others are untouched. Other tornadoes may be 1.6 kilometers or 1 mile wide. Tornado safety. Before a tornado hits, you may notice dark or greenish clouds in the sky. You may see rotating clouds in the distance. If you see a tornado or a tornado warning is announced, go to the basement of the building right away. You may also go to an inside room of a building where there are no windows. Tornadoes, sometimes called twisters, can travel more than 160 kilometers or 100 miles per hour. Derechos. A derecho is a strong windstorm that travels straight over a long distance. A derecho may happen when a series of thunderstorms form over a large area. The winds of a derecho can reach speeds over 160 kilometers or 100 miles per hour. These storms can be a few miles wide or hundreds of miles long. Derechos form most often in the late spring when the air is warm. The storm may last for hours. They can severely damage trees, homes, and power lines. Derecho safety. Derechos bring strong, damaging winds. They can make sure nothing outside can be blown away or cause further damage. They can also gather flashlights and other emergency supplies in case wind damages power lines. So these are some of the things people can do during one of these storms to help stay safe. The straight line winds of a derecho cause heavy damage. Hurricanes. A hurricane is a large storm with strong winds and heavy rains. A hurricane starts as a storm above warm ocean water. Rising warm air causes the storm to rotate. When the winds reach 119 kilometers or 74 miles per hour, the storm is called a hurricane. Some of the strongest hurricanes can reach wind speeds over 249 kilometers or 155 miles per hour. Hurricane clouds rotate around a calm area near the center, called the eye. When a hurricane hits land, it can bring intense winds and cause flooding. Hurricanes weaken over land. The warm water that fed the storm are left behind. Hurricane safety. Scientists track hurricanes as they form and move. People may also be asked to prepare to leave an area to stay safe. People prepare for heavy rains and strong winds. Did you know hurricanes from over the Atlantic Ocean and the Eastern Pacific Ocean? These same types of storms that form over these oceans around the world are called tropical cyclones. Hurricane winds can cause great damage. Now, if you look at a hurricane and a tornado, both of them have swirling strong winds. The main difference is hurricanes begin over water and tornadoes begin on land. Winter storms. Winter storms occur when warm air and cold air meet. Snowstorms, blizzards, and ice storms are all winter storms. A snowstorm is a winter storm that drops heavy snow on an area. A blizzard is a snowstorm with very strong winds. Blowing snow makes it difficult to see. Blizzards bury plants, cars, roads, and buildings under snow. They can cause power outages because of the high winds and heavy snowfall on power lines. Ice storms cover all surfaces with a slick layer of ice. The ice can be a thin coating or a layer several inches thick. Power lines and tree branches often snap as ice builds up during these storms. Winter storm safety. Staying inside and off roads is important during winter storms. Listen to news reports. Roads and airports may close during storms as snow collects on the ground. After a storm, people are advised to remain off the roads until they're cleared. Okay, so that takes us to the end of our reading. Now we're going to go in and watch our digital interactive titled Weather Events.
A blizzard is a severe snowstorm that occurs in very cold temperatures. Blizzards can only occur in areas that are cold enough to have snowy weather.
So the first one that you're going to put into your types of weather is a blizzard. And you're going to put in the details that you learned about blizzards in this section. Once you've completed that, we're going to move on to the next one, which is called freezing rain.
Freezing rain happens when precipitation falls from the clouds as rain and the rain freezes as it lands on a surface. Freezing rain can happen in temperate climates as long as the ground temperature can get cold enough to freeze the rain.
Okay, so freezing rain is going to go into your second type of extreme weather. Your third type is going to be thunderstorms.
A thunderstorm is a severe storm with heavy rain, thunder, lightning, and sometimes hail. Thunderstorms can happen in almost any climate, but they need warm, moist air to form.
Next, we're going to write about tornadoes.
A tornado has the fastest winds of any storm. Tornadoes can happen any time of year, but they most often occur during spring and summer. They are most likely to occur in the areas midway between the equator and the poles.
All right, next we're going to talk about hurricanes.
Hurricanes are very large storms that begin over a tropical ocean. The surface of the ocean needs to be warm in order for the hurricane to form. This usually only occurs in tropical areas near the equator. A flood is when a naturally dry area becomes covered by water. A flood can occur anywhere, but they usually occur near other bodies of water. Floods can happen in any region for a variety of reasons, including a large amount of rain, melting snow, or a hurricane.
So your next area is going to be floods. After you've completed floods, we're going to talk about droughts.
A drought is when a place gets much less precipitation than normal over a long period of time. Drought can happen anywhere that has had a change in weather patterns that results in less rain and snow falling.
All right, now we've covered all of the different things that you need to complete your weather events page on page 101. Go back and rewind the video if you need to go through those different types of weather again, and use the information from the textbook that we read to also give you additional details and information about these types of weather. Now, what you're going to do is you're going to prepare a presentation where you're going to talk about each type of extreme weather. So this is an activity that we're either going to do in class, or if you're working from home, you can complete it at home using Google Slides. You're going to label the type of extreme weather, add in a picture with a description. So tell me what the picture is showing, add in an interesting fact and what you remember about it using your text evidence. So use the information from your textbook or use the information from the digital interactive to put in interesting information that you remember about that particular kind of extreme weather. So there's 7 kinds of extreme weather, so you need at least 7 slides. Then you're going to answer, how were other presentations the same as yours and how are they different? Once we've completed that, we're going to go on to our section on, or our performance task about becoming a meteorologist. You're going to use a weather map and other information to write and present a weather forecast. So what question do you hope to answer? And then you're going to take a look at the weather map, the data chart, and other information that you find, and you're going to create a graph to show the information that you collected. Circle the information that you're going to use to write your forecast, and then answer the questions on the following page. Write your weather forecast, so write what you think the weather is going to be like based on the information you gathered. Describe how patterns helped you make your weather forecast. Were you able to answer your question? And then our essential question here, think about the photos of extreme weather we saw at the beginning of the lesson. How did the weather change in each of the weather situations? So you'll go ahead and put down your complete answer right there. Again, if you need to see those photos again, here's our first photo, our second photo, our third photo, our fourth photo, our fifth, and then our sixth, our last one. Go ahead and complete your workbook pages. Remember to review your vocabulary and your reading before your quiz at the end of this lesson. If you have any questions, let me know. Otherwise, I hope you have a great day, third grade. Take care. Bye-bye.